All right, welcome to Lecture 13, conclusion of E259. Today's meant to be a wrap-up of the course. Not only will I give you a taste of some of the other XML-related stuff that's out there, I'll also give we can begin with a couple of examples of some of the AJAX stuff that unfortunately was only broadcast on video, if you had a chance to view that. But David Lieberman was our guest lecturer in absentia a couple weeks ago, and he's a gentleman who works as a full-time developer over at the business school, where they've been doing some neat things and some sexy things with AJAX and the like with a lot of their web-based software. And this very much is all the rage. And we introduced it in part in this course because even though decreasingly does AJAX actually imply a use of XML, because there are alternatives to using XML, namely JavaScript or JSON, JavaScript object notation, that's the spirit of where AJAX began. And it's remarkably useful in terms of making much more seamless user interfaces, which is where we'll begin today. And then we'll take a few moments at course's end just to look back at where we started and wrap up there. So this is a course that I actually teach over at the college, Computer Science 50, and this is the website that we use for it. And I just thought we'd use this as a very real but nonetheless simple example of where AJAX can be useful. So we have this page over here called Office Hours, and we have a whole bunch of teaching fellows in this course. It's much larger than this course. And so the teaching fellows hold office hours in for a couple hours a week in the Harvard Science Center, as well as in a virtual classroom online using the Illuminate software. And because it's such a large list of office hours, it's sort of nice, we thought, if we could have the list of office hours dynamically update itself, so that not only is it blinking a la 1990s blink tag which office hours are in progress, but we also wanted this list to update itself, so that if a student needs help right now at this moment, they can just look at the top of this list and they'll see the next possible office hours. But we wanted this is a computer science course, we wanted things to be sexy, so if a student just happened to leave the page up for a good hour, and therefore the Monday 7 to 10 p.m. office hours are over, well, we didn't want that data to just stay there stale, blinking in progress, when clearly that's no longer the case. And the obvious alternative in the typical HTML world is to do what? To update a page? I mean, hit the refresh button or hit F5, right? So you actually reload the page. But there's really no need to do that anymore. Now, there are hacks that have existed for years, or there are solutions like the meta refresh tag, if you're familiar. But you got to refresh the whole page, and it's kind of annoying because the page will every minute or whatever disappear for the user, even if they're about to click on something. So that's not ideal. Moreover, it's only this rectangle that we wanted to change. The links on the left are not going to change, and most of the stuff elsewhere on the page isn't going to change. So enter AJAX, which if you didn't have a chance to pull up last time's video, AJAX, which used to stand for asynchronous JavaScript and XML, but increasingly implies just this general technique, is a technique, if you will, that allows you to, with JavaScript, make an embedded HTTP call from the browser back to some server, grab some new data, and then insert that data into the web page, as opposed to grabbing a whole new web page. So what I decided to do when I wanted to set up this office hours script was I wanted this rectangle to update itself every minute, so that we were never more than 59 seconds out of date. So how did I go about doing this? Well, first let's take a quick glance at the source code of this page. And it's going to be a little small, but I'm going to scroll down to what's actually interesting about it. So I'm going to scroll down to, I think, the bottom. And let me actually just check what the most relevant portion is. Yep, let's go here. So even if you're not really familiar with JavaScript, you've probably seen snippets of it over time. And embedded in the middle of this page is a script in JavaScript that does a few things. And one, it adds a listener, so to speak. And this is actually using one of Yahoo's libraries, which I'll pull up the URL of in a minute. And I think David Lieberman in his lecture actually emphasized this as a wonderful library. Long story short, just like it's been a nuisance for years in the browser world for having different standards and approaches for implementing the same idea, it's the same deal with AJAX things. So Yahoo has their UI, Yahoo User Interface Library, which is a wonderful and fairly robust set of libraries that really standardizes how you can make use of AJAX techniques. In other words, they take away all of the stupid cross-browser issues and allows you just to make API calls, no matter what browser the user is using. And so I use that here so that I can say the moment this page loads, that is, listen for the page loading, execute this function called OHS1, Office Hours 1. Okay, well, what is that function? Well, you see it right below. The only thing this OHS1 script does, this office hours 1 script, is it executes a function called, just to play along here, something called async request. It's using the get method, and let me highlight it just so that everyone's on the same page. And what is it getting? Well, it's getting what's in the second argument there, /cs50/ajax/officehours.php $type equals something. Okay, so it's by default, it's not specifying any type. And then there's a third argument, which is a little funky, and it's a JavaScript trick, but it's passing in curly braces with success:/OHS2. So JavaScript, as the acronym did or does imply, is asynchronous, which means that you don't, like a typical browser transaction, sit there twiddling your thumbs waiting for the response to come back. Rather, you proactively tell the function what function to invoke when the HTTP response comes back. So in this way, can you do multiple things simultaneously in a web page thanks to multi-threading and the like. So what this is saying is, go ahead when OHS1 is called using get and fetch that URL, whatever it returns. When it is in fact returned in its entirety, invoke the function on success called OHS2. And I actually have been a little bit lazy here. I didn't even bother handling a failure case because I figure if it fails, frankly, who cares? Just don't update the page. The students don't necessarily need to know that that transaction failed since it's just an office hour script. But what's the second function? Well, it too is pretty simple. So I'm doing document.getElementById. So what this actually means, quite simply, is that there is some element, it turns out it's a div, that looks like this in the XHTML of the page, that initially actually is empty. It's an empty element. It has nothing in it. But what I'm saying is get that element by its ID and then get its property called inner HTML. And as that suggests, that is the HTML inside of, nested inside of as children or descendants of that element, and then plug into that value o.responseXML.documentElement.firstChild.data. Okay, a bit of a mess, and perhaps not obvious the first time you code this up, but what's going on? Well, O is just the name of the local variable called, the local variable passed to this function, the argument, and it's an object, and it happens to be an HTTP request object, which we'll look at in a moment. Response XML means get the content that was returned, not as ASCII text per se, but as an object, as a response XML. Now dive into that XML and get the document element, the root of the thing, and then grab the first child, sort of a leap of faith, and grab its data. Now what is in there we'll see in a moment, but really all that's saying is take the response, grab whatever's inside the root element, and plug it into the web page here. So aesthetically, what that call to the officehours.php script is doing is it's returning all of this stuff dynamically. In fact, let me go ahead and refresh the page and watch that it takes a moment for all of this to happen. So notice by default, there's nothing in this div element. I let the page invoke the moment it's entirely loaded, that JavaScript function, OHS1. It takes a moment to grab the data from the server. OHS2 is invoked, and OHS2, as we saw, plugs that data into the web page. And so you'll actually see, you typically won't see a flicker on the page just because IE renders it pretty nicely, but every 60 seconds, you'll notice I'm telling that same function to get invoked again with this line here. I set a timeout for, actually it looks like, yep, every minute, so every 60,000 milliseconds, invoke yourself again. So it's kind of neat that with just, 6 or 7 lines of code, JavaScript code, you're making use of this really neat technology or technique known as AJAX. So what's going on the server's end? Well, clearly this file is getting pulled up, officehours.php. So let's take a look. This is just HTTP GET, so I don't need any fancy tools to see what's going on. I'm just going to go ahead and plug in that URL, and let's see what the browser is getting back. Well, thanks to IE7's rendering, what you see here is a nicely formatted XML document. Arbitrarily, the root element is called, apparently what? Update. I just gave it a name because it's updating something. And then nested inside of that is its data child, which is one huge CData section, which is also a bit of a sloppy technique, at least some might say, because what I'm doing is on the server side with that PHP file is I'm just generating all of the HTML that I want to plug into the page because frankly it was so darn easy to just get this up and running. Then all I'm doing in that JavaScript code then is getting the document elements, first child, the data, that is that whole CETA data section, which is just, turns out, HTML. And because I'm trusting myself to have made well-formed HTML and valid XHTML on the server, I'm just pasting it in to the original HTML document. So I'm just sort of taking the original document and inserting more XHTML here, which is making it bigger conceptually. And so every 60 seconds, this content gets downloaded, and thanks to some logic in the PHP file, which I won't bother pulling up, we are getting a web page that updates itself every 60 seconds. So the moment the clock strikes 10:01 p.m., Abe Pasalia's office hours, gone. And he'll appear at the bottom of the list because the thing constantly sorts itself, which is the whole motivation here. Okay, so any questions on just what you might do with Ajax or even how you might do it? That's perhaps in and of itself not enough to sort of get started with this at home, but a great place to start, frankly, is Google UI, U-W-Y-U-I. You'll pull up the whole Yahoo interface library, which has a wonderful set of other libraries, but the one in question is called the Connection Manager. And what's great about UI stuff is that not only does it come with the library code, free open source, also a bunch of examples. So in fact, let me just pull up an arbitrary other example just to give you a sense of how you can bootstrap yourself. And realize, incidentally, that this, much like a lot of the stuff we've been doing, is language independent. Even though we played in this class with Java, at the end of the day, we were really talking about server-side web development, and we happen to choose Java. But for Ajax, clearly it's not tied to a particular server-side language. I chose PHP. You could be using a JSP or servlet to spit out dynamically that same kind of HTML content. It just turns out that CS50's website in the backend is all implemented in PHP. But nothing we just saw is inherently tied to PHP. You could have been using Perl for all it cares, or Ruby, or Python, or anything to spit out that content. Let's see. Connection Manager examples. Dynamically loading. Do we want to do this? How about this? Retrieving a Yahoo RSS weather feed. Let's see what this example looks like. All right, so I'm going to go ahead and type in F for Fahrenheit. I'll do our zip code here, 02138, get weather RSS. So there too is an example of Ajax, because the most obvious feature is that the whole page did not just reload, but rather some new content got inserted. And I'm guessing what happened was I clicked that button, it got an RSS file, aka XML file. Some of the data was pulled out either via JavaScript or just one big C data section and plugged in to the web page. So some neat tricks that you can do with relatively minimal code these days. So for more on that, take a look at this last URL there for the Yahoo UI library, and just incidentally know, and I'm going to go in reverse order in a second, that the W3C has gotten involved in the standardization of how all of this stuff is done from the client-side perspective, trying to standardize XHTML HTTP request object, so to speak. Frankly, it's probably immaterial from a developer's perspective, since there are wonderful libraries out there like Yahoo's that just abstracts away all of those details for you. So it's a great starting point. The UI? Google, I think, too, has an Ajax library as well. I've not used it myself, but I think if it exists, it too standardizes some of this stuff. But at the end of the day, it's not even all that important which one you use, so long as you're supporting the platforms you want. And Yahoo makes a concerted effort to keep things cross-browser compliant. So David Lieberman brought out a couple of other points last week, which are great to know and also great to conclude the course on, because even though they are not, say, standards in the W3C sense, they're certainly popular and perhaps de facto standards out there. So we didn't spend all that much time writing DOM code. However, the curious thing is that if you spend more time in the world of Ajax and writing JavaScript code, what you get with JavaScript, unless you're using some third-party library, is DOM functions. So you navigate an XHTML DOM by calling get first child, then maybe get next, get sibling, get sibling, get sibling. And it's not a very nice interface to use when you, especially if you know a priori where the data is in the document you want. You can't just dive in with like an XPath expression unless you're wrapping things with some other library. But in the world of Java and, say, server-side development, there are some alternatives to the DOM API we looked at. And recall that we used this in Project 1 when you did the attribute converter code, most likely, and maybe even later you integrated some as well. Well, in the world of DOM, if you wanted to create a new XML document that has maybe nothing other than a root element with some text below it, like "this is the root," these are the kinds of lines of code that you would have to write. And even if you couldn't write this off the top of your head, things like document builder factory probably sound familiar at this point in the course. Takeaway is that there's a bunch of lines of code that you have to write to get a fairly conceptually simple job done. Enter JDOM. So JDOM is just a third-party library that's meant to be a Java-specific DOM-like library. So in JDOM, to do that same task, you would just create a new document, create a new element, set the text of the element, bam, add it to the document. So JDOM is meant to facilitate DOM-like functionality, but getting rid of a lot of the more generalized hoops you have to jump through when using the DOM proper API. So it's a very popular API if you want to do in-memory traversal or retrieval of data, and if better yet, there exists something called JXPath, which is similar in spirit, but allows you with, as you might be able to infer, far less code, grab specific data from an XML document that's been built up into a DOM with something that's like an XPath expression up there. So these two blocks of code are again equivalent. This is sort of the standard way, so to speak, that you might do it in DOM with traditional APIs, and the JXPath API just lets you get the job done a lot quicker, dare say, or with it writing fewer lines of code and clearer code, perhaps. So just realize that these things are out there, and even though we've emphasized a lot of standards in this class, particularly stuff that came out of the W3C, that doesn't necessarily mean it's always best. But what we've at least extracted from all of those standards are the basic concepts, which I do think you'll find in any of these third-party libraries, particularly even those that are designed to be more developer-friendly than standards-friendly. Okay. Oh, and incidentally, these are the kinds of methods we're talking about and the kind of standardization of this object known as the HTTP request object. And all this is referring to is the browser client-side functionality that lets AJAX work. But more on that in any online tutorial. All right, so long list here, but terribly brief comments on each of them, since what we did in the course was front load in lectures 1 through 12, the stuff that I think is particularly useful in terms of getting real work done. And this is sort of a teaser as to possible solutions in the pipeline for problems that you may have encountered or questions that might have come up in looking at some of these other languages, and then we'll wrap up with a couple of comments on the course and the content itself. So XForms is an attempt to standardize or make separate the structuring of user input from the description of user input. That is, taking data and presentation apart in the context of forms. So consider this. This is a form that you could very easily mark up in XHTML, but if you looked at the source code for this, it would be the markup code, and then the actual data, like the names of these fields, would be very much intermingled with a form element, with input elements, and so forth. So what XForms purports to do is instead something like this. So this is maybe an HTML version or XHTML implementation of this. No surprises here. You've been writing code like this for projects 3 and 4. But XForms purports to do something like this. You would again have just a typical, say, XHTML document, but what you would have in there is more of a formal structuring of things, which I'm going to wave my hands at some of the details, but dive into the part that's most relevant to the picture we just saw, and note the following. So at the top of this thing, we have a select one element, the idea of which is to select one of the elements that follow, but there's now a semantic tagging. What is the caption for this particular form field? What are the specific choices that you can have? As you can see with the XForm choices element, enumerating each of the items. What's the value, but what's the caption for those inputs? So really there's just yet more semantic markup of the pieces, the components of this form than currently exist in, say, HTML4 or XHTML1. So that's the idea, the spirit of XForms. I would say in the few years that the recommendation and the drafts thereof have been around, I don't think the world has seen terribly much progress. In fact, it's hard to find a plugin that supports XForms, but that was the idea of this, if you encounter it. Processing. This aspect of it is neat, though. The idea of clicking submit, though, the submit button in the context of an XForm, is that what gets submitted is data that itself is semantically tagged, which makes parsing on the server side potentially much nicer and much cleaner. You don't just get an array of get variables or post variables, rather you get an object, an XML hierarchy that tags the data similarly to how it was structured in the actual document. So the idea is that this thing, this envelope, a la SOAP, is what would actually get submitted to the server. So that's a nice feature, but I don't think we've seen much forward traction on this. So Xlink you've actually seen. Xlink, as the name suggests, is an attempt to standardize links in various XML-related languages. Trivia question for tonight would be, where have we seen this? SVG. So SVG, we saw a very simple example, and some of you used it in your Xtube markup. If you wanted to have a link, so you could click part of the SVG and actually get whisked away to a URL, you actually specified xlink:/href, which was an attempt by the W3C to standardize this stuff, which actually makes good sense conceptually, since with all these languages, these XML-based languages, why continue to reinvent the wheel? Right? We saw this with SVG and schema. We saw a borrowing of data types in one language for another. SOAP as well borrowed schema's data typing scheme almost in its entirety. So same idea here. Why should every language come up with its notion of a hyperreference if we can't just standardize that as well? So that's what Xlink is all about. And I'm actually going to wave my hands at some of the details here, which you're welcome to peruse if you're curious, because there's way more in this recommendation than that idea alone. But I think it's just perhaps best described as that, since who really cares at the end of the day how it's standardized, but rather that it's standardized. So there's a whole discussion of what are called simple links and extended links, but I think we would end up dwelling on something that might not ever prove of interest to you. So quick look at XPointer. So XPointer is an attempt within XML documents to empower you, the developer, to dive into a very specific point within an XML document. With something like XPath, you really only have the means of expressing element node level content. Give me the text node. Give me the element node. But in some contexts, if you wanted to dive further and specify a very specific part of, say, an XML document, using XPath-like syntax, XPointer, the spirit of it, allows you to do that. So if we have some file called bar.xml, even in the form of a URL, and you want to dive in and extract some piece of it, with XPointer, can you point specifically to some piece of content in that document by way of augmenting its address in this fashion. So this is very similar in spirit to fragment IDs, which in HTML speak allow you to click a link and then jump to a relative location in the page. Same idea here. You have an XML document and you want to refer to a specific point in the document, and you can do so with this XPath-like expression. And the spec even lets you get more specific, whereby you can specify individual characters within a node by using this crazy dot notation, which I'll also wave my hand at. But sometimes there's clearly lots of attempts out there, I think, to standardize things that are of, say, less immediate value than, say, the XSLT recommendation. But I'll include it there. Funny that I should use that word.Xinclude is an attempt to standardize the means by which one XML-based language includes a document of that same type. So we saw this ability in XSLT, and we saw this ability in other languages as well, schema, whereby you can include conceptually one document in another. If everyone keeps doing this, why not standardize it? Xinclude is an attempt to do exactly that. So the idea is that using something like this element here, could you specify in any XML-based document that you want to include rowlingbio.xml in this document, so that you can navigate not only the current document, a la XSLT, but also this imported or included document, so to speak. This one I kind of included just because it's kind of funny. In that it gets its own recommendation. So XML base is an attempt to standardize how you specify what the base URL is for a document against which all links get referenced. So it's an underused element, but in the HTML world, you can specify a base equals quote unquote, and then specify that any relative links in this document should be resolved relative to this base address. So here's a whole recommendation that allows you to do exactly that across XML-based languages. So the idea here is that if you wanted to include a file called rowlingbio.xml, and you wanted that file to come from this base address, you would use something in XML base's namespace as opposed to thexinclude namespace. So silly as some of these, the time that's been spent on some of these things I think might feel, you are increasingly seeing this, especially with XML-based APIs out there. In fact, just recently was I looking at some of Google's own APIs, their GData API, that they use across a lot of their free code libraries for calendar, for their search API, for what else do they have now? Some of their RSS feeds and the like, Gmail as well. So you see that the underlying transport mechanism that these guys are using increasingly is just XML. And they're proclaiming to the world, here is our schema, and you can read up on the schema, the documentation therefore. But because they're bringing in other standards into their own data standards, namespaces make that hugely possible as well as easy. So just this idea of having an XML document, even if it's not meant for human eyes, but for computer consumption, increasingly are you seeing multiple languages being tied together by way of these namespaces, and specifically these prefixes. So if you recall our focus in one lecture on namespaces, simple as the idea is, it's increasingly useful out there. All right, well, what about encryption? So there are certainly some data that you might have been exchanging in, say, Project 4, like credit card numbers and the like, that sort of screams, please encrypt this, so that you're not just sending it across in the clear. So what's the most obvious solution to that problem? You want to keep your data private or secure. How do you do it? Or what do most websites do to keep it secure? Yeah, just SSL, HTTPS. So you run a web server that just uses this end-to-end encryption. It encrypts everything that goes across the wire. Typically, this is done for performance reasons, not using public key crypto from end to end, but rather, if you're familiar with this, public key crypto is used to generate a unique key, a unique key that is subsequently used in something that's faster than, say, RSA, but rather AES or triple DES to actually encrypt all of the data, all of the web page's contents going from point A to B. Well, if only some of your data is sensitive, it's sort of silly to bother spending CPU cycles, cheap as they increasingly are, on encrypting data when you might just want to encrypt a subset of your data. So what XML encryption is about standardizing how you can encrypt individual nodes within an XML document without taking this heavy-handed approach of just wrapping the whole darn thing in SSL. And this is perhaps compelling because even these days in some of the most popular websites, like a lot of these mail clients like Gmail and Yahoo and Facebook and MySpace, and I think many, if not all of those examples, do use SSL when you log into their site, but then they punt you back to unencrypted pages. They've authenticated you. The rest of the stuff doesn't need to be encrypted, and they do this for performance reasons, so that they don't have to have as many SSL connections concurrent as a bank, for instance, might have. So it's perhaps reasonable to say most of your data you don't need to have encrypted because it is expensive, even if it's decreasingly so, but you still want to encrypt some of that data. So the idea of XML encryption is to standardize stuff like this, where you have an XML submission from client to server or vice versa, and it's an attempt to standardize how you specify that parts of these documents, certain nodes, are in fact encrypted. XML key management, meanwhile, is just an attempt to standardize how you manage keys between parties A and B in this world. And XML signature is similar in spirit in that it attempts to standardize how you would digitally sign these documents. So just FYI when it comes to that, but I would say none of these last three have you really seen in great use just yet. SSL is still the solution of choice. Okay, so a couple of words, really, I guess we'll wrap up tonight. on data modeling, some of the lessons that have hopefully come out in this course over time. So these are just some ideas that are perhaps maybe become obvious to you over time, but perhaps not back in Project 1 or so. But realize that much like one of the lessons of Project 2 was, whereby xcube.xml was certainly not structured in an optimal way for some of the queries some of you want to execute in your projects. Recall that part of the problem set had you implement a converter.xsl file to massage it into something that was more conducive to efficient queries. But that's not really the point of XML typically, when it's at least used as a transport mechanism, just to get data from A to B. So one of the things to bear in mind is that if you can avoid it, certainly since bandwidth isn't always cheap, you should try to cross-reference data from within one document rather than just include identical instances of Harrison Ford next to every movie that he was actually in. Think back to Project 1, where we actually did these sort of references from one element to another. Might make searching a little less performant, but it depends on what your goal is, to get the data from A to B or to search it once it's at point B. Think, too, about what XML gives you that relational databases don't give you. So for instance, even though in like a SQL table you might have fields like address 1, address 2, address 3, city and state, well, you don't need to impose those same naming constraints, for instance, because you have this implicit notion of order in XML documents. So instead of trying to replicate that same naming schemes, bear in mind that in XML an address can look just like this, and you can even strip out 2 of those fields, say 2 of the redundant street fields if they're just not needed, because you don't have to think so much in tabular form, but you can think much more so in so-called object-oriented fashion, which XML allows you. And then there's this sort of common question of what do you use, how do you implement certain pieces of data? Do you choose to implement them as child elements or as attributes? So this is something that you've probably encountered even in the course of the class. Off the top of your head, give me one compelling reason that you should just make almost all of your pieces of data attributes. In what context might that approach have been advantageous, if any?
I think for parsing, if you get an element, you can just say, okay, give me a list of all the attributes. And then
Right. So with SACS in particular, and even I am guilty of this, if you're using a SACS API for whatever reason, maybe simplicity, maybe because the document's so darn big you don't want to read it all into memory and then traverse it, it's really annoying to have to grab data from an XML document using SACS if you want to go after child elements or descendants, because you have to maintain state in your own code and sort of remember where you are in order to get out, say, a child of foo. Whereas if you're just grabbing data that are attributes, well, as soon as you see a foo element, there are all of its attributes. And that is compelling if the goal is really to get at the data and you don't really care what the data looks like underneath the hood. Of course, the price you pay for making something an attribute is what? Can't have any child elements. And in some sense, you paint yourself into the proverbial corner, because if in the future you do want to extend the definition and you realize, damn, we kind of need to keep around now a user's middle name in addition to their first name and last name, can't really do that necessarily if you have committed to something like attributes. So there's not necessarily ever a right answer to these questions, attributes versus child elements, but just appreciating the differences in the different contexts is perhaps a valuable takeaway. So a word on this, perhaps a plug if I may, for those of you interested in continuing along this line of server-side development, God forbid with me at the helm yet again. So this is a new course at Harvard Extension School this spring, E75 Building Dynamic Websites, and there's the course's description. The course's website is online at that URL if you're at all curious and want to check it out. But this is meant to be a course that caters ideally to students who have just a bit of programming background as well as people who are full-time developers, and spends an entire semester on what it takes to not only implement but also manage your own website using predominantly PHP as the server-side language, XHTML and CSS as the client-side stuff, but also a significant focus of this course will be on AJAX and actually writing JavaScript code, writing the server-side code to back it up using, again, PHP. But we'll also begin the course with a look at, well, if you don't have an FAS account, how do you go about running your own website? If you're not actually the guy who manages the hardware at your office, how do you go about setting up your own website? And what we're going to do is provide students with an account on a commercial server service, dreamhost.com, if you're familiar. So students will have their own Unix accounts on this system. Students will be tasked with buying for the price of about $8.95, their own domain name via DNS, which we'll focus on a bit in the course. Students will map that domain to their server account, and then they'll play in this real world, so to speak, environment throughout the entire semester. And we'll migrate away, as we did in this course, in this standardized Harvard-run environment to something that is very easily translatable to an actual real-world development and deployment of a web server. So more on the website if you're at all interested. But questions for now?
So how much of it is Ajax?
I would say that it's meant to be about a quarter to a third Ajax.
And this is Ajax with PHP, not with Java?
With PHP, yeah. But frankly, Ajax at the end of the day is largely a client-side technique. And yeah, no, that's fine.
But if the fundamental concept is grabbed from this Ajax PHP combination, how easy or how difficult is it to translate to Ajax Java?
Oh, good question. I'll repeat for the camera. So given that this course focuses on LAMP, which is this acronym for Linux, Apache, MySQL, and PHP, just how transferable are the skills to, say, a Java world or another language? Very straightforward, to be honest. I mean, we're using PHP in this course so that we focus on one framework overall. But at the end of the day, the course is more about these techniques and these concepts, and it's pretty trivial, frankly, to swap in a different server-side language for the Ajax stuff. So for instance, you saw earlier that what was generating CS50's web page was, because I told you, a PHP file. But at the end of the day, all that PHP file was generating was something that looked like this. So if you can imagine spitting out this in a language of your choice, then that is sort of as simple as it gets in terms of swapping in another language. So the early part of the course, though, to be sure, we'll focus on PHP and learning PHP, maybe the first third to half of the course. But once we get to the Ajax stuff, it's sort of immaterial what server-side language you're using. Go ahead.
I guess Ajax basically derives from JavaScript.
Yes.
How important it is in this certified course to have a JavaScript background?
No background. So the official prerequisites for the course are a programming experience in any language. So what I'll assume of students is that if I say you want a loop, you want some recursion, you need that will all be rather obvious what I'm talking about, even if they know that from the world of C++. So the course is going to teach students HTML and CSS, though less so there. The focus of the course will be teaching PHP and teaching JavaScript in the context of these techniques. So no JavaScript background will be assumed. Other questions? Yeah?
Since you brought this slide back up, I was wondering, let's see, the server is generating XHTML, correct, and sending it back. I guess I had this image of the server sending back a more compact representation of data in XML and having the JavaScript expanded into constructs, either, I guess not really expanded, but rather do the DOM calls driven by the XML.
Both approaches are possible, and this is why I disclaim this as sort of the lazy man's approach, where I just decided it was so easy to just generate the XHTML on the server side. I wasn't going to create more work for myself by doing it client side, and there's upsides and downsides. Very little development time went into the PHP script that spits out this code, and very little time went in clearly to the JavaScript code, because I got the job done in about 7 lines. However, one, this file is much bigger than it needs to be, because just look at all the TD tags and no wrap attributes that I'm sending across the wire, which might be an issue for some websites. So you can actually very easily, well, you can almost just as easily have your server-side code spitting out not XHTML content, but for instance content like this, an OH element, inside of which might be a time element, inside of which might be 2100/time, and so forth. And so what the browser receives is true XML markup, not XML markup with one huge C data section. And what you can then do in your JavaScript code using DOM code is actually navigate the tree that this gets built into, so that you dive into office hours / time conceptually, pull out its value, and then plug in specific values. This makes good sense when you are more bandwidth constrained, or if you want to actually manipulate the data in some other way. But frankly, for a lot of applications where all you're trying to do is update the page, this approach works great, ugly as the huge C data section may seem. So we'll focus on all such techniques, and in fact, we'll focus not only on the XML part of this XML aspect of AJAX, but also the JSON aspect of AJAX, where you return not even XML, but one big string representation of a JavaScript object. And you don't even bother parsing because you create the JavaScript code dynamically on the server side. So that's another approach altogether. Yeah. Mm-hmm.
If the server sends back XML as you described there, the result from XML HTTP request object is a DOM reference?
If the server spits out what? Can you say again?
Thought I saw something that implied that if the return from the server, that in some way, if XML were returned from the server, it would be manifested in the JavaScript world as content in an XML DOM.
Yes, correct. In fact, that was the argument called O in the return function. So yes, the browser handed to me an XML a DOM representation of the file, effectively wrapped in that thing called an HTTP request object. Yeah.
I'm not sure how relevant this is. A while back, like back in the 90s, it seemed that the common method for creating dynamic websites was, say, Perl and CGI.
Mm-hmm.
Is that still being used at all, or is that kind of just legacy technology, or how does that fit in with anything that we've been doing this semester?
So it's a good question, and I would say CGI and Perl, I mean, you can write CGI. So CGI just refers to, it means Common Gateway Interface, and it boils down to writing server-side code that happens to spit out a web application, like HTML. So you can write CGI code in C, C++, Perl, and so forth. It's in recent years, to be sure, that the world has seen more web-specific languages arising. PHP's primary purpose in life is to generate HTML code, and you would see exactly that in a course like this, frankly, because of how tied the language and its libraries are to HTML. I mean, Perl, I think, is still used. Personally, I have not used Perl for web development in several years because it's just not nearly as conducive to generating code like this. And the syntax, I still use Perl frequently for scripts, and when I want to whip up quick and dirty scripts, or if I want to get at, if I don't care about GUIs and spitting out HTML. But I would say that it's not nearly used as much. Ironically, much of Harvard's infrastructure is still written in Perl. There's performance implications, though, since it's not necessarily the best language for that, in that, to my knowledge, I mean, there exist plugins for PHP that allow you to cache the bytecodes from PHP, so it can be compiled just in time, but then you save the compiled version. I presume Mod Perl, I guess, mimics that same idea. But I think the world is seeing these other languages like Java in the form of JSPs and servlets being used more. I mean, C# is used in the context of ASPs in the Microsoft world. PHP is hugely popular today. Ruby on Rails is increasingly popular. So I would say that something like Perl and CGI proper is still used, but decreasingly so, only because I think subjectively there are better options out there that are just more tailored to the environments. And some here may agree or disagree. Does anyone still here use Perl for a lot for web development?
It also depends on the kind of domain you're talking about.
Sure, depends on the domain.
In the bioinformatics world, it's still heavily used CGI part, though it's changing pretty fast.
Sure.
Because this human genome project when it started, we didn't have these kind of things. People basically use flat file CGI in order to build up web pages, throw data around. And it's still being carried on, though it's changing. But I think PHP still has some built-in advantage in terms of efficiency and bigger data sets.
Mm-hmm.
Though I don't know how to do that and work with the development, but I get to meet with people who still think they have probably an edge over that. But again,
Okay.
presentation and all that stuff is not really that.
Okay. Yeah, I mean, frankly, I think what's compelling increasingly is the amount of documentation. I mean, we in CS50 for the kids chose PHP because the user's manual is just so damn good, frankly, and it's hard to find really good Perl references out there. And when you do want additional functionality in the world of Perl, you have to go to like CPAN and actually download additional modules. Online references, though. I mean, PHP's online documentation is akin to JavaDoc, which frankly I think is one of the hugest, most compelling features of Java. It's just that they've standardized the damn documentation and that everyone tends to use that same format. It's hugely compelling. So that too, I think. Plus in PHP, there exists a function built into PHP for almost anything you might possibly want, which is, perhaps a little disgusting, but when you just care about getting a job done, it's wonderfully useful. So. But at the end of the day, it's partly a religious debate as to what's best and what you should use when. So I think I promised in the first lecture, or showed in the first lecture, that we always ask students, or in the past we've asked students about what their takeaway was. And I think these were the two quotes that I gave in the very first lecture this year, which frankly I think certainly mimic my take on this whole world. XML is beautiful, but as with beautiful people, it is neither easy to get along with nor quick. So that was kind of true a few years ago, but the fact is that XML is being used increasingly, and frankly it's hard to find publicly accessible APIs these days that aren't using XML. So the world has, for better or for worse, sort of realized that yes, it's verbose per one of its own guidelines, and yes, it's not necessarily the most efficient representation for data, but it's an open standard. It's completely language independent. It's human readable. And coupled with increasing bandwidths and CPU performance and the fact that it does, as text, compress really well anyway with something like gzip, it's becoming increasingly used. So I think that's less of a concern, this first one today. And the last one, XML strength, is its wide adoption and excellent tools. XML itself is not that exciting. I mean, that too, I think, is an important takeaway, because it's the fact that there exist so many off-the-shelf tools, from Xamarin to Xerces to other languages, is hugely compelling. And for instance, just to make this more real, when I first implemented E259's website years ago, E259's website is actually driven by Perl as well as by XML files. So in E259's website, we have pages like the lectures page, which is actually generated with an XML file. So just to give you a taste of this, if I log into the E259 website and then open our XML file called lectures.xml, what you'll see, if you're vaguely familiar with what's been on that page all term, are things like slides and syllabus and audio and video. So this was an arbitrary XML format that I came up with a few years ago because I just wanted to semantically tag things for the website and then let something else actually spit out the very uninteresting XHTML code. Moreover, I wanted the TFs and I to be able to update this easily and not have to pull up a MySQL prompt. I didn't want to have to just deal with CSV files because this makes things more obvious as to what's what, and so we marked it up in XML. At the time, though, the only way that I could actually apply XSLT to this XML document was to, on Harvard's web server, install a JVM and then spawn Xamarin and Xerces by doing a system exec call from the Perl code, which is just, long story short, a mess to have things very decoupled. And in fact, when we update the page, for instance, if I scroll down here to decide that, you know what, I don't want anyone to see today's notes, I'm going to make them unavailable by changing that to 0 and go over here and reload the page, it takes a damn long time for the page to update because the Perl script that's being used is, again, spawning a shell to run a JVM, which itself takes time to load, and then finally the page gets rendered. Well, this is not a big deal this is why then I had to write 20 more lines of code to actually cache the XHTML so that the next time a student visits the page, it's not regenerated, it's just pulled from disk. But that was just a nuisance. But you do see now that I did take away the slides from tonight. So enter the world of, say, other languages, whether it's Java or PHP. And in the world of PHP, for instance, with CS50's website, we have this same idea. So for CS50, we have a lectures.xml file, and I slightly changed the format, but it's exactly the same spirit. But with CS50's website, if I make a change to this, the change happens instantaneously. The reason for which is that PHP 5 has built-in XML and XSLT support. And in fact, navigating an XML document in PHP actually boils down to something like this. So this is a file called index.php, and this isn't meant to be a tutorial per se on PHP, but note that all it takes for me to parse this XML file is to instantiate in PHP what's called a simple XML element. And by passing it the name of that file, lectures.xml, it returns to me a DOM, effectively. If I want to then traverse that DOM, I can simply do this. For each week, as $week, so that's a for loop, go ahead and echo the current week's number, which is just like an associative array. If you've not seen the syntax before, it's a hash table. So get the number attribute from this week element. And then if I want to dive in deeper, for each week's resources element, resource child, go ahead and iterate over that using this. So long story short, using this arrow notation and bracket notation, a language like PHP just gives you immediate access to content in the XML file, similar in spirit to XPath, but using syntax that's specific to the language. So the takeaway is that, again, if you're just trying to solve some problem and you need to represent your data in some way and you want to actually then process that data using some logic, increasingly is XML a very nice choice for such, because you don't need to re-implement the wheel, you don't need to re-implement the wheel, namely an XML parser, because most environments now are coming with them off the shelf. And frankly, that's compelling, I think, because you can focus on problems that are much more interesting than parsing data from disk. So the goals of this course, we promised, were to focus on things that were practical, actually implementing some real applications and exploring some of the possibilities for these environments, and also along the way emphasizing things from the bottom up, from having implemented your own parser really in the course's first lecture to by project 4 just assuming that you have access to a much better parser that someone else wrote so that you can focus on the more interesting problems. And hopefully what you've gotten out of this course, beyond an exposure to as well as a great loss of free time, is experience in a whole bunch of languages as well as APIs and tools. So hopefully you'll find one or more of those useful in your own work or academic lives here on out. So let me take a moment here to thank you for all your time this semester. I'll certainly stick around for a while with any questions. Otherwise, I think we're officially a wrap. So good luck on your final projects. Thank you. We look forward to seeing them.
I don't know that.